Hey everybody, Mr. Covey here, and this is the first video. It's Rationals video number 1 for our learning check number 9 here. Okay, it's our last learning check for the class. Cool, so let's wrap this out. So we're going to be focusing on graphing these new type of functions called rational functions. Okay. And in order to graph them, we're going to use a combination of things we've already talked about when we've been graphing stuff and some new ideas, okay? So first, take 30 seconds and just maybe think about or even look back, take a couple minutes. What are some of the important things, features, that we've used to help us graph stuff? So like, what have I asked you to find about functions to help us graph them? You want to graph something, what do you find? Take a minute to brainstorm a little list. Okay. Maybe some of the things that came to mind were the vertex, which we did with quadratics. A big thing we focused on with polynomials, we're finding x-intercepts. For both of those, we talked about finding y-intercepts. Trying to think of other things. Those are the big ones. For rational functions, finding x-intercepts is going to be huge. Finding the y-intercepts is going to be huge. They don't have vertexes. It's kind of like polynomials, they don't have vertexes. But finding x-intercepts and y-intercepts is going to be a good start to help us graph it. Okay? So first though, what is a rational function? Well, the word tells us a lot. It's a rational function because that first part there is ratio. What's a ratio? A ratio is a fancy word for a fraction. Okay, so what is a rational function? It's a fraction function. Okay, so anytime you come to a function and they say, hey, f of x is a big old fraction. It's got stuff on top with x's and squareds and cubes and blah, blah, blah. And it's got stuff on bottom with x's and squareds and cubes and blah, 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 blah. That is a fraction function, which is a ratio function, which we call a rational function. Okay. Now, there's a couple of other features of rational functions that are going to help us graph them, and they're kind of like unique to rational functions. The biggest two things are they have horizontal asymptotes and vertical asymptotes. Now you might remember just from last learning check what an asymptote is. An asymptote is a line that a graph gets really close to but doesn't touch. Okay? So both of these are lines the graph gets really close to but doesn't touch. Okay? Now, what is a vertical asymptote? Well, it's the vertical line the graph gets close to and doesn't touch. So it goes up and down. What's a horizontal asymptote? It's just a horizontal line the graph gets really close to and doesn't touch. Yep. So a lot of our rational functions are going to have a combination of horizontal asymptotes and vertical asymptotes, and those are going to help us get an accurate picture of the graph. We're going to have y-intercepts. And what's a y-intercept? It's where it crosses the y-axis. You guys know that. What's a zero? Well, zero is actually just another name for an x-intercept. So it's important to be fluent in the different vocab. Okay, but when someone talks about zeros, they're just talking about x-intercepts. What are x-intercepts? Where it crosses the x-axis. So what we're going to focus on is figuring out these 4 different things for these rational functions, and then based on the horizontal asymptotes, vertical asymptotes, the x-intercepts, the zeros, and the y-intercept, we're going to get a picture of what the graph looks like. Cool. Okay, so let's actually do some problems. Okay. As we just did in class, it's going to all come down to factoring. Okay, this is really all about factoring. So we got a rational function here. It's a ratio. It's a fraction function. We really need to factor it. Okay. So we're going to factor the top and factor the bottom. Pause, take a minute to factor that, please. Actually pause and give it a try. Cool. Okay, so that's what it should have factored to. Right, so being able to have the original version and the factored version is going to be helpful because sometimes we're going to look at the original and sometimes we're going to look at the factored depending on which thing we're looking for. Okay? The easiest thing to find is the y-intercept. You find the y-intercept the way you always find y-intercepts. You find y-intercepts by plugging in 0 for x. Okay, I'll jot that down. Yep. You take your original or the factored one. It's easier to take the original. You plug in 0 for x. Just use your calculator. Type it all in. You should get out 12 over 20, which is 6 over 10, which is 3/5, which is 0.6. So your y-intercept is, it's nice to write as a point, it's 0, comma 0.6. Okay, that's just a point in your graph. 0.6 is like 0, right? It's right there. Okay, so now we have 1 point on our graph. Okay. 0 is, remember, our x-intercepts. The way you find x-intercepts is by setting the numerator equal to 0. It's important to know. Numerator equal to 0. So you're going to set this top equal to 0. Now, the reason that we factored it is because that's the first step in figuring out when the top equals 0. In fact, it's the biggest step. Once you have that numerator factored, what are the solutions to the numerator equaling 0? Well, when does x plus 3 times x minus 4 equal 0? At -3 and at 4. And those are your x-intercepts. X equals -3 and x equals 4. Okay. We should write them as points. -3, 0, 4, 0. Okay. Cool. Lastly, the horizontal asymptote. This is the most confusing one. You should probably jot this down somewhere. There's really 3 possibilities. In terms of what the horizontal asymptote is or how you figure it out. Okay. It all depends on the degree of the numerator compared to the degree of the denominator. Those are the 2 things you're talking about. Remember, degree is the highest exponent. In this case, the highest exponent in the top is 2, and the highest exponent in the bottom is 2. The first possibility is that the degree of the numerator, DON, equals DOD. The degree of the numerator is the same as the degree of the denominator. If that's the case, then you look at the ratio of the leading coefficients. And I know that sounds like a lot of vocab there, but you guys know this stuff, ready? So if your degree of your numerator equals the degree of the denominator, which is the case here, you look at the ratio of the leading coefficients. What's a ratio? Fraction. What are leading coefficients? Well, they're the numbers out front. So you look at the numbers out front. There's nothing there, so there's a 1. There's nothing there, so there's a 1. And you make it into a fraction. So your horizontal asymptote is going to be 1 divided by 1, which is 1. So if the degree of the numerator equals the degree of the denominator, you look at the ratio of the leading coefficients. Okay? We'll talk about the other situations in a second here. So in this case, the degree of the numerator does equal the degree of the denominator. So our horizontal asymptote's 1. We should write it as y equals 1. Okay. And we should drop a horizontal line at y equals 1. Got it? Now, I don't want to throw too much at you at once, so we're just going to stick to these 3 for now. But what I want you to notice is we don't have a complete picture. Like, I don't know what this graph exactly looks like just from these points in this horizontal asymptote. So I'm going to call over my friend. And I'm going to use that to help me get the complete picture. Once we have Desmos here, once we have more features, which we're going to talk about in the next video, we'll be able to do a little bit better job with our Desmos. But we're always going to use Desmos to help us out because these graphs do kind of look weird. We have at least like a starting point. Okay? And so if you pull over your friend Desmos, you get that the graph looks like this. Okay. So if you kind of pull that to the side, pull our guy to the side here, you see that our points are good. And what we've captured is kind of this inner part here. And we didn't get these outside parts, and we'll get those more later. But it'd be nice to kind of try and put it all together here and say, oh, okay, so our graph looks kind of like upside down parabola. Let me grab it. It goes through those points. It doesn't cross that horizontal line. And then there's this weird little like L things going on here. And here. And again, once we get more features, we'll be able to get a better idea why those L's are there. It looks something like that. Okay, let's give this one a try. So y-intercept, plug in 0 for x. Okay, go ahead and do that. You should have gotten 0, 2 for your y-intercept. Okay. Zeros, remember you set the numerator equal to 0. When does x minus 6 equal 0? That's 6. So 6 to 0 is our x-intercept. Horizontal asymptote. We got to look at the degree of the numerator compared to the degree of the denominator. Now, what's the degree of the numerator? Well, it's just 1. Okay? Because there is no exponent there. The degree of the denominator is not 1, it's 3. Okay, so we have different degrees here. We need to go back here. So first possibility is degree of the numerator equals degree of the denominator. Second possibility is degree of the numerator is less than degree of the denominator. And that's the situation we have here. The horizontal asymptote here is just y equals 0. It's easy. So your degree of the numerator is too small. Smaller than the bottom is bigger, and you just get 0. So here our horizontal asymptote is going to be at 0. I know what you're thinking. I thought we weren't supposed to touch that horizontal asymptote. Sometimes these rational functions break the rules, and we'll see that kind of. But in general, a horizontal asymptote is something you get really, really close to, and you usually don't touch. Sometimes it touches. Again, we don't have a real complete picture here until we get more features. So use your friend Desmos. Type it in. Get a kind of weird looking graph like this. So let's touch that. Again, why does it look like that? We'll get a better idea once we get a little more features. Something like this. Shoots up there, and it comes up, goes through there, and then it goes real close. The last possibility for horizontal asymptotes, we might as well talk about it now. If you can have the degree of the numerator equal to the degree of the denominator, you can have the degree of the numerator be less than the degree of the denominator. The other possibility is that the degree of the numerator is bigger than the degree of the denominator. And if that's the case, there is no horizontal asymptote. So it's not something you have to worry about. So those are our three possibilities. Cool. Let's run through this one. Y-intercept. You guys run through this, see where you're at. Pause, give this a try. Factor the denominator just for fun. Okay. So you should have gotten, excuse me, y equals 0 for the horizontal asymptote. That's because the degree of the numerator, there wasn't even an x. The degree of the numerator was 0. There isn't even an x. The degree of the denominator was 2. So it's a situation where the denominator is bigger than the numerator. Degree of denominator is bigger than the degree of numerator. Y equals 0 is our horizontal asymptote. Yeah. For zeros, we had to set the numerator equal to 0. But again, there's not even an x in the numerator. So when does 24 equal 0? It's not a thing. Okay. Y-intercept, we plugged in 0 for x, we got -2. Again, we don't have a lot to work with here because we still haven't learned the last piece. But if you look at the Desmos graph, okay. So there was no y-intercept like we thought. There's no x-intercepts like we thought. It's kind of an upside-down parabola here. And then there's two little L-shaped things, which we're going to see a lot of with these rational functions. So something like this. Okay. Oops, I shouldn't really touch that last one. Going back to number 2. I would like to factor the denominator. I forgot to factor the denominator. We didn't use it, we didn't need it, but for the next thing we're going to need it. So why don't you take a second and remember how to factor this denominator. I'll give you a reminder. It has 4 terms. You're going to need to use grouping. Just for practice, go ahead and try and factor that. Okay, you should have gotten 2x squared plus 1 times x minus 3. That's that factoring by grouping. Cool. Okay. Let's do number 4 together here. Cool, and this will be the last one we do for this video. Again, I want to factor all of this just to practice factoring. So when I look at that numerator, I am thinking both those things have an x. I can take a GCF of x out. I'm going to take an x out of both those. I'm left with x minus 2. In the denominator, I also have a GCF. I can take a 2 out of both of those. But when I take the 2 out, I'm left with x squared minus x minus 6. This part, I can actually factor more. What multiplies to -6 and adds to -1? -3 and +2. So, sorry guys. Actually factor it a little more. Keep the numerator how it is. Still have that 2, but now it's going to be x minus 3 and x plus 2. It's going to be really important that we can factor it right. It's going to help us with the new stuff we're going to talk about in the next video, but also just with where we're at now. So to find let's start with our y-intercept. Plug in 0 for x. Yeah, 0. Again, I'm plugging into the original over here. Type in your calculator. So my y-intercept is just at the origin. To find the zeros, I set the numerator equal to 0. Okay, I'm going to get 2 possibilities, either x equals 0 or x equals 2. I already got x equals 0 here, so x equals 2 is another x-intercept. Find a horizontal asymptote. I look at the degree of the numerator compared to the degree of the denominator. You'll see that the numerator's second degree, got a little x squared there. Degree of the denominator's second degree, so they're the same degree. Degree of the numerator equals degree of the denominator. We got to do this ratio of the leading coefficients idea. So what's the leading coefficient in number 4 for the numerator? Well, it's 1. What's it for the denominator? 2. So we got to make it into a fraction, 1 over 2. And y equals that is our horizontal asymptote. So we have a horizontal asymptote at 1/2. So right here, you got this little line that the graph's not going to cross. Again, we don't have a real full picture of what this looks like, but we can type it in Desmos real quick. Put it together with the pieces that we were able to figure out ourselves. That's kind of the way. It should all kind of line up. And it does. We got those points there that we found, and so upside down parabola, and we got those two L's there. And a lot of the graphs end up looking like this. Not all of them, but a lot of them. So our graph looks something like this. And we'll talk about those all parts more in the next video. Okay? Thanks for watching, guys. That concludes this video.